Hello and welcome. Today we are going to talk about systems of linear equations and row operations. So, systems of linear equations and row operations or elementary row operations. Now let's take an example. Simple system. In an algebra class, college algebra or intermediate algebra, let's say 3x plus 2y equals 5 and 4x minus y equals 3. This is a system of equation 1, 2. Now in an algebra class, remember this is linear algebra, not just algebra. In an algebra class, this is how you would do this. If I were you, I would take equation number 1 and add it to equation number 2 multiplied by 2, because then I can create a negative 2y. So let's see. So 3x plus 2y, that's the left hand side of equation number 1, plus twice equation number 2, so 8x minus 2y equals right hand side, first one 5, second one 3 times twice 3, so 6. Then when I add 3x and 8x, I get 11x, and 2y with negative 2y, it's gone, equals 11. So x equal 1, right, when divided by 11. Now at this point, what you need to do, you need to plug this back in one of those equations. So let me take the second one. So x equal 1 in second equation, you get 4 times 1, 4, minus y equals 3. So from here, y also 1. So our solution is x equal 1, y equal 1. If you plug them back in our first equation, you can check. So 3 times 1, 3, 2 times 1, 2, 3 plus 2, 5. Correct, right? Now, in our last videos, we were talking about matrix multiplication. Now, look at this system, this red color system, and look at this. So look at those numbers in front of x and y. 3, 2, 4, negative 1. And if I make this into a matrix, we call it the coefficient matrix. And if I put x and y like this, and if I put 5 and 3, this blue color one is same as red color system. Now let me explain why, and it should be clear by matrix multiplication. Let's double check by actually multiplying it. Again, first one is 2 by 2 matrix, second one 2 by 1 matrix. So when you multiply these two, you should get 2 by 1, which is this matrix. Now if you actually multiply this row with this column, that's how we multiplied matrices. So 3x plus 2y, and then 4x, next one 4x minus y, right, and equals, so this is 5, 3. See, we are just putting it in a matrix. So this is one reason why we learn these matrices. Now we can solve this red color system by converting into a matrix system, and we can easily solve it using row operations. But before we do row operations, let's 5x minus y equals 8, 3x plus 8y equals 2. A system like this, as another example, 5, negative 1, 3, 8, x, y equals 8, 2. Simple as that. You just keep writing. First one we call the coefficient matrix. This is another example. Coefficient matrix. This one is the variables, unknowns. and this one is the right hand side column matrix. Again, this one also a column matrix. Now let's take this guy and solve it. So before we solve it, first thing, when we are about to solve it, so solving, first thing we put this in an augmented matrix. That means you write down those numbers and draw a line or dotted line, and you forget about this column, but you take this 5 3, you put it here. So this is known as augmented matrix of that system, right? Now what we are going to do, we are going to do some operations exactly like that, that what we did in this red color system. Those operations without x and y, we are going to perform some operations. But first, we have to learn those operations. So let me go to a new page. Row operations. So there are 3 operations that you have to remember. Multiply a row through by a non-zero constant. Second operation, interchange 2 rows. Third operation, add a multiple of an equation to another, or add a multiple of a row to another. Now, before we actually do that, let's have a look at these 3. What's going on here? So let's say multiplying a row through by a non-zero constant. First one. What does this mean? So let's say 3x plus y equals 2. An example. If you have this equation is equivalent to this or to this. What's going on here? Here I am multiplying the whole thing by 2. Here I am multiplying the whole thing by 10. So whenever you have an equation n equals b, you can do whatever you want to this equation as long as you do it to both sides. I mean, not exactly whatever, almost whatever, because you cannot here non-zero. You cannot just divide by 0 or multiply by. For example, let's say 10a equals 10b. This is okay. 5a plus 5 equals a plus b plus 5. See, as long as you do that thing to both sides, you are going to get an equivalent equation. That is the idea behind that first row operation. Second one, interchange 2 rows. Now this is even simpler. So for example, our example, what was it? 3x plus 2y equals 5 and 4x minus y equals 3, right? Now, this system is same as this, right? I'm just rewriting it in the other way around. So that's what it means. So in the matrix world, you can do that as well. So that should be clear. And the last one is actually the one that we use for the elimination or back substitution. And last one is let me go back. No, I think I erased it. So last one is the technique we let me write down this again and explain. So 3x plus 2y was 5 and 4x minus y was 3. Remember in the beginning of the video I did something like this. I had one times I wanted to get rid of y, so twice 2, and I get see what I am doing here, adding a multiple of one equation, so in the matrix world it become a row, to another. So thereby I get my solution. So that's why we have these three row operations. I think the idea behind the row operation should be clear. Now let's go to a new page and let's start dealing with our system. So 3x plus 2y was 5 and 4x minus y 3. Now the augmented system was this: 3, 2, 4, negative 1, augment, either line or dotted line, that's fine, whatever you like. Now, using this row operations, this is how we write it down. Now, this you need to get used to this kind of notation. Different textbooks have different notation, but I like to do it like this. So, I would like to, I do nothing to my first row. So, 3, 2, 5, I keep it there. Second row, what I'm going to do, I'm going to add first row and second row 2 times R2. So I'm going to multiply second row by 2 and add it to first row and keep that result on second row. So I replace my second row by this operation. That's what it means in this notation. So 3 plus twice 4, 8, 11. And then 2 plus twice negative 1, negative 2, so 0. 5 plus twice 3, which is 6, so 5 plus 6, 11. See, I got that. And then at this point, I would like to R2 divide by 11 and keep that result in the same place on R2. So I don't do anything to my first row. 1, 0, 1, right? Now, at this point, I would like to, you know what? At this point, actually, if somebody wants, you can stop, because now in this one, it's clear x equal 1, because see, here 1, here 1. But, you know, let's move a little bit forward and simplify this into until we get to a nice form. So I would like to interchange. So this is how we will denote by interchange or switch. So you can do that operation. 3, 2, 5. Okay. Now at this point, I like to make this 3 disappear. I want that to be 0. So the easiest thing to do here, negative 3 times R1 plus R2 on R2, right? Again, these operations are not unique. Different people might have different operations, but the answer should be unique. So 1, 0, 1, and negative 3 times 1, negative 3, and when you add, we get 0 here. And 0 times negative 3, there's 0, and then I get 2 here, and then I get negative 3 times 1, negative 3 and 5, I get 2 here. So at this point, I would like to R2 divide by 2, because I want to make this also 1, so, and keep it on R2. I get 1, 0, 0, 1. See, what I did was, I did this operation and convert this red color part, look at here, into identity matrix, and the result is I'm getting 1, 1. So that means, see, 1x plus 0y equals 1, so x equal 1. 0x plus 1y equals 1, so y equals 1. We have the same result as before, and this is much easier. Not just easier, I mean, if you know this, what's going on, you can solve difficult system, not like using actual equations, because much easy and comfortable. So let's see another example. How about this? Let's take 3 by 3 one. X minus 2y plus 3z equals 9 minus x plus 3y equals negative 4. 2x minus 5y plus 5z equals 17. Now we have three equations. So this system is equivalent to 1, negative 2, 3. So you just write down those coefficients, negative 1, 3 and 0. Now this is a tricky place. Why? Because in the second equation here, there are no z's. So you have to put 0 here before the augment. 2, negative 5 and 5, and then the constants 9, negative 4 and 17. Okay, so our goal is to do many operations and come here 1 0 0 0 1 0 0 0 1, and you get some numbers here, and those are x y z. Let's see how to deal with this. Hopefully we have enough space in this page. Let's see. First operation, I would like to make this guy 0. So what I need to do, add r1 and r2, because I have 1 here, right? I can use that and put that on r2. So I'm not going to change my r1. So 1, negative 2, 3 and 9. And when I add them here, I get 0, and negative 2 plus 3, 1, 3 plus 0, 3, and 9 plus negative 4, 5. And I keep this one. In later next video, there's another thing. You can do more than one operation at this point. If I wanted, I can do another operation here, but we have to be careful. But since this is the second example, let's go one by one. Next, I would like to make this guy 0. So how about r1 times negative 2 plus r3 on r3. So when we do that, negative 2 times 1, negative 2, and we don't change this, so it's better to write them. And even I don't change second one, so and last one, so negative 2 times 1, negative 2, 0, and negative 2 times negative 2, 4, plus negative 5, I get negative 1, and negative 2 times 3, I get 6, and negative 6 and 5, I get negative 1, and negative 2 times 9, negative 18, plus 17, I get negative 1. See, now this guy is much close to this, still not yet, but step by step we are going there. Next one, I may need to write down small numbers. Let's see. Next, I see I can make this 0 by adding r2 and r3 and keeping it on r3. So 1, negative, let me use another color so it's clear. 1, negative 2, 3 and 9, I don't change that. Second one, I don't change, 1, 0, 1, 3, 5. Third one, I replace that by adding r2 and r3. So 0 plus 0, 0, 1 plus negative 1, 0, 3 plus negative 2, 2, 5 plus negative 1, 4. See, now if somebody wants, at this point, they can stop and you can solve 2z equals 4. So z is going to be 2 and do the back substitution. But let's do some more operations and try to get to here. And also, one more thing. When you have this form, we call this an echelon form because you see, you have this, and also this is a upper triangular matrix. We'll talk about these things later. Because below main diagonal, everything is 0, right? So that's something to note at this point. But anyway, let's move forward. So Now what I would like to do, divide R3 by 2 and keep it on R3, because I can make this guy into 1, right? That's much better. So 1, negative 2, 3 and 9. Oops, I don't have enough space. Let me erase this for a time being. So R3 by 2 on R3. So 1, negative 2, 3 and 9. 0, 1, 3 and 5. 0, 0, 1, 2, right? Now next we can make this into 0. So let's see. I think I'll have to erase this one, otherwise I don't have enough space. But you can go back and watch the video. So at this point, let's erase a little bit more. Let me write down this here, then it's much clearer. 1, negative 2, 3, 9, 0, 1, 3, 5, 0, 0, 1, 2. Now I would like to make this disappear. So you can pause the video and think the operation. Now I can use this one. So R1 plus 2 times R2 on R1. If I do that, I'm going to replace R1 by, 1 plus twice 0, it's still 1. Negative 2 plus twice 1, so negative 2 plus 2, that's 0. 3 plus twice 3, 6. So I get 3 plus twice 3, 6. So 9. And 9 plus twice 5, 10. So 19. And 0, 1, 3, 5, 0, 0, 1, 2. Now we can make this one disappear by doing what? What if I do this? So R1 plus negative 9 times R3 on R1. Again guys, we can do more than one operation in the same augmented system. I'll do it in my next video, since this is the first example with 3 by 3. Let's take one operation at a time. So R1 plus negative 9. So 1, 0, 9 and negative 9, 0. 19 minus 9 times 2, 18. So 19 minus 18, 1. See, now this is much better. And 0, 1, 3, 5, 0, 0, 1, 2. The only place I have problem is this. I can get rid of that by using R3. So R2 plus negative 3 times R3 on R2. Because I need to get rid of that 3. So 1, 0, 0, 1. And last row, we are not doing anything. So we are replacing C on R2. So 0, 1, because R here they are 0. Only place it's going to affect here and this here. So 3 plus negative 3 times 1 is negative 3. So 0. And 5 plus negative 3 times 2, negative 6. So 5 plus negative 6, 5 minus 6, negative 1. And we are done. See, This one is the identity matrix. That means 1x plus 0y plus 0z equals 1, or in other words, x equals 1, y equals -1, z equals 2. And I hope you understood what row operations are and how to use them. Let's do more examples in next video. And that's it for today. Thank you.